Hi guys, in this video we're going to study about polar coordinates and complex numbers. We're going to combine the topics and make conclusions from complex to polar. So let's take a simple example here. We have a real axis and an imaginary axis. So remember, every complex number is in the form a plus bi, right? And we want to convert this complex number into polar form. So from prior knowledge, we know that the value of A is equal to R cos theta, and the value of B is R sine theta. Okay, so we can take out R. Don't forget about the I here. So let's write I, leave the I and move the B over. So I times R sine theta. Now, if you take out R as a common factor, we're left with cos theta plus I sine theta. So what we can do is we can simplify this to be R in short form. Cos theta plus I sine theta, we can simplify it to be cis theta. Now what is cis theta? C-I-S in short. So if you have a complex number Z is equal to A plus BI, Z can be R cis theta in complex form. Now, write the complex number 1 plus I. We're going to write the complex number 1 plus I in polar form. So where's 1 plus I? 1 plus I is in the first quadrant. So let's draw a diagram. So there's 1, and plus I is you're going 1 unit up, 1I. That's a real axis. That's the imaginary axis. Now there's angle theta, and that's R. So what is R equals to? R is equal to √2. And this is a 45-degree triangle. So theta is equal to pi by 4. So how can I write this in complex, in polar form? You have to say Z. Remember, this is the complex number, and this is the polar form. Now, so Z is equal to R cis theta. So R, what is cis theta? Cos pi by 4 plus I sine pi by 4, which is 45 degrees. That's a full form of cis theta, CIS, right? It's just a short form for remembering. Next question, write the complex number √3 minus I. So where's √3 minus I? √3 minus I, it's nice to look at the point. So for understanding purposes, √3 minus I is going to be in the fourth quadrant, and the angle will be negative. Okay. So -1, and that's √3. So this is the imaginary axis. That's the real axis. So we get square root 2, that's -1. Sorry, this is √3. This is √3 and -1. So this should be 2, right? And that's the angle theta. So opposite of hypotenuse. So theta should be -30. Theta is equal to -30 degrees, and R is equal to 2. So you can write the complex number in polar form, which is R cos theta plus I sine theta, right? So R cis theta. R is 2 cos theta. What is theta? -30 plus I sine, what's theta? -30. Now remember, you can simplify this further. I say there's 2 cos 30, because cos of negative angle is positive. It's in the fourth quadrant. And remember that angle is negative theta. Sine of -30 is negative sine 30. Right, so you can simplify it like this as well. Now, what is product of complex numbers? So if I'm finding the product of Z1, Z2, if I'm finding the product of Z1, Z2, It's just going to be R1, R2 cis theta 1 plus theta 2. That's it. So so you still have to multiply the two radiuses, the two radii, and open bracket cos theta 1 plus theta 2 plus I sine theta 1 plus theta 2. There's a big full form like this. We need to write it out. This is just in short. What happens when you take a quotient of complex number? Remember, Z1 is equal to R cis theta 1 and Z2 is equal to R2 cis theta 2. So what is Z1 divided by Z2? That's basically R1 over R2 cis theta 1 minus theta 2. That's it. What's the reciprocal of a complex number? So if the complex number is Z, which is R cis theta, the reciprocal 1 over Z is basically equal to 1 over R cis of negative theta. That's it. Those are the three formulas that we need to know. So find the product of the following complex number. Remember, complex number 1 is 1 plus I. We already proved it above. 1 plus I is root 2 cis pi by 4. And Z2 is the second complex number, which is 2 cis negative, what was it? Was it pi by 6? 30 degrees. 30 degrees is pi by 6. Right, so I can convert it to degrees, no issues. Cis 45, convert this to degrees, 2 cis negative 30. I want to find the product of these two complex numbers. So I want Z1, Z2. It's going to be R1 times R2, R1, R2 cis theta 1 plus theta 2. So let's add them up. What's R1, R2? Root 2 times 2 is 2 root 2. Cos, what's theta 1 plus theta 2? 45 minus 30 is 15. Plus I sine 15 as well, because we are adding up these two angles, right? We are adding up negative 30 and 45. Now, that's 2 root 2. We got an issue here because cos 15 plus I sine 15. What is cos 15? So you have to use, we should have just wrote it out like this instead of writing 15. Let's write 45 minus 30 because we are adding it up. Plus I sine 45 minus 30 degrees. Remember, we need to simplify this. So this is compound angles, cos 45, cos 30 plus sine 45, sine 30 plus I. So let's move this to the side because you have to do this compound angle twice, like, right? Plus I, bracket this, sine 45, cos 30 minus cos 30, sorry, cos 45, sine 30. Okay, so there's 2 root 2 still on the outside. This is what? Cos 45 is root 2 over 2. Cos 30 is root 3 over 2. Plus sine 45 is root 2 over 2. Sine 30 is half. Plus I, open bracket. Sine 45 is root 2 over 2. Cos 30 is root 3 over 2. Root 2 over 2 times root 3 over 2. Yeah, that's root 2 over 2. Sine 30 is half. So what we are getting here is continuing 2 root 2. That's root 6 plus root 2 all over 4 because the LCD is the same. Plus I, that's root 6 minus root 2 all over 4. Now you're going to take 2 root 2 and multiply it on the inside. So we're going to take 2 root 2 and multiply it out on the inside. So the 2 and the 4 will cancel out. So that will become 2. And that will also become 2 because you're multiplying it out twice, right? So you're multiplying here and you're multiplying there. So now root 2 times root 6, root 2 times root 6 is root 12. Root 2 times root 2 is 2, divided by 2, plus I. Root 2 times root 6 is root 12, and root 2 times minus root 2 is minus 2, divided by 2. Now we can simplify this further. This is 2 root 2, because 4 times 2 root 3, sorry, 2 root 3 plus 2 divided by 2, plus I, that's also 2 root 2 minus 2 divided by 2. Now, remember the top we can divide by 2 and the bottom we can divide by 2. So we just have root 3 plus 1 as a real part. The top we can divide by 2 and the bottom we can divide by 2. So you got root 2 minus 1 with the I. Now let's take these two complex numbers and multiply them out, right? Let's take this complex number 1 plus I and root 3 minus I. But how are you going to check if you're going to multiply this out? Yeah, of course you can't multiply it out like that. 1 plus I and root 3 minus I. So my final answer is this by simplification. But we wanted to write in polar form. Okay. Okay. So we just wanted to find the product of the following complex numbers in polar form. So you're supposed to write it in polar form and then find the product. So, okay. So we wrote this complex number in polar form. That's the polar form of the complex number. And then now we are trying to find the product, and that's my final answer. What if we just took the product of this and this? So let's see. Mode 1. Mode 1. Shift mode complex. Sorry. Mode complex. Option 2. So 1 plus I, close bracket, root 3. Root 3 minus I. Yeah, so I'm getting 1 plus root 3 plus root 3 minus 1 I. So same answer when I multiply them out. Oh, it's not supposed to be root 2, it's supposed to be root 3. That's supposed to be root 3. Yeah. So that's your answer. Moving on to the next part. Now, what is de Moivre's theorem? De Moivre's theorem is what happens when we raise a complex number to the power n. See, because z is equal to a plus bi. What is z to the power n? Z to the power n is a plus bi to the power n. But we already know that z is equal to r cis theta. So de Moivre's theorem says z to the power n, make it r to the power n, and cis n theta. Take n and multiply by the angle. So this is this is literally not possible to do, but this is possible. That's the reason why we study complex to polar form. So de Moivre's theorem 2 plus 2i. So let's say z is equal to 2 plus 2i, right? Convert to polar first, and then take to the power 10. So it problem becomes much more easier, right? So 2 plus 2i is 2 and 2. We got 2, 2, 2i. That's the real axis. That's the imaginary axis. You can clearly see the angle theta is 45 degrees. And the radius is the square root of 8. R equals 2 squared plus 2 squared. So 4 plus 4, root 8, which is 2 root 2. Because 4 times 2 is 8. Square root of 8 is 2 root 2. So we know r is equal to 2 root 2. Z is equal to r cis theta. R is 2 root 2. Or let's just leave it as root 8. It's fine. R is equal to square root of 8. Cis theta. Cis, what is theta? Theta is 45 degrees. Right. Now what are we doing? We're going to say z to the power 10. Z to the power 10 is 2 plus 2i to the power 10. We're going to say root 8 to the power 10. cis 10 times 45. So it's easier to work in degrees. Root 8 to the power 10 is 8 to the power half to the power 10. And this is cos 450 plus I sine 450. Now moving on this side, that's 8 to the power 5 because half times 10 is 5, right? And then simplifying this, cos of 450, take away 360 from here, you will be left with cos 90 plus I sine 90. Now, sine of 90 is 0 and cos of 90 is 1. So the answer is just 8 to the power 5 into 1 plus 0. So what's the answer? 8 to the power 5, which is approximately 8 is 2 cubed, so 2 to the power 15. That's your answer, 2 to the power 15. Now, what happens when you're finding a roots of complex numbers? To find the roots of complex numbers, example, you have a complex number z, and you want to find the root of z. Z is equal to r cis theta. So when you're finding the nth root of z, right, we call this, the nth root of z is r to the power 1 over n cis theta divided by n. The only problem is you need to add 360k, right? So the only problem is you need to add a general solution, 360k. Where k, what's the values of k? K can only go from 0. K is a counter 0, 1, 2, right up till n minus 1. So this here represents the roots of complex numbers. So now I need to make, let's call it W K. What does WK represent? The roots of complex numbers. Let's demonstrate this equation by means of an example. So I'll do this example on the last page. Okay, let's just do it here to understand this formula over here. So to understand that formula, let's understand this formula here. Note. So additional question, I want to find the cube root of 8. What is the cube root of 8? I want all the answers. So what we say, let z be equal to 8. Now z is obviously a real number, but put it in complex form. So you're going to say plus 0i. So draw this on the complex plane. The radius is 8. Sorry, the a value is 8, but there's no height. So there's 8 here. So where's the radius? The radius is 8. So r is equal to 8. And what's the angle? There is no angle. There is no inclination. So theta is equal to 0 degrees. So and theta is equal to 0 degrees. So you say z is equal to r cis theta. R is 8 cis 0 degrees. So what is z? Right? We are trying to find now the cube root of 8. Z is equal to 8. So you can say the cube root of z is equal to 8 to the make it wk, where wk represents the roots of complex numbers. You can use different variables, right? So you're going to say 8 to the power 1/3, right? Or cube root of 8. You can just say cube root cis 0 degrees plus 360k over 3. Okay. Why are we saying over 3? We have to divide it by n, which is 3. And the values of k can only go from 0, 1, and 2. So what is k equals 0? That's the first root. That's the second root. And 2 is the third root. Okay. Sometimes they use the value of p. the pth root. Anyways, let's find all the roots here now. So the 8 to the power 130 is the cube root of 8, which is 2. And to simplify this, this is cos 360 over 3, because 360 divided by 3 is 120k plus I sine 120k. Now, if the value of k is 0, you have cos of 0. So we're finding W1, which is 2 cos 0 plus I sine 0, because the value of k is 0. Sine of 0 is 0, cos of 0 is 1. So the answer is just 2. If you're finding W2, that is 2. K is 1 now, cos 120 plus I sine 120. So you're going to say 2 times. What is cos of 120? That's negative, is in the second quadrant. So that's negative cos 60. So cos of 60 is half plus I sine 120 is second quadrant. So sine 60 is the reference angle. 180 minus 60 is 120. So that's going to give me root 3 over 2. 2 times negative half is negative 1. 2 times this second part is root 3i. Right? So let's check if this answer works. What is a cube root of 8? The answer is 2. This is the real part. The other two numbers are complex part. So if you find the cube root, shift cube root of 8, we're getting 2. So what is 2 cubed? Taking the answer, we're cubing it. 2 to the power 3 is 8. Now let's take negative 1 plus root 3i and cube it. So we're going to take negative 1 plus root 3i, close bracket, and we're going to cube it. Aha, see, we get the answer 8. So we got the second root. And what's the third root? 2. So the value of k is 2 now. Cos 240 plus I sine 240. Both of them are in the second quadrant. So 2 times, both of them are in the third quadrant. So that's negative half. And the second part is also negative. So negative I root 3 over 2. So that's negative 1 and negative root 3i. So obviously, if one of the answer is this one, then the second one has to be a conjugate. So we got 3 answers. So the cube root of 8 is actually equal to 2, negative 1 plus root 3i, or negative 1 minus root 3i. It has 3 different answers. 2 of them are complex, and 1 of them is a real root. Look, you can use different values for W. I just use W, right? You can use R. For N, you can actually use a P, doesn't matter. Okay, so now, okay, so what they have used is K and P now. Remember, I used K over here. So now they are using N and P. They're finding the P at the root. So no problem. We can just say W instead of W, W K, we can say Wn is equal to R to the power 1 over P cis theta plus 2 pi n over P, because the pth root. Okay, so that those are the roots of the complex number. Now let's see, what is the value of, we want the value of this, we want the value of theta plus 2n pi over P for the third distinct root of the cube roots. Remember, we're finding the cube root. So the third root is when n is equal to 2. So third root. So we're going to say theta is already 7 pi by 6 plus 2. We want the third distinct root. What is the distinct root? The third root will be, remember, we're looking at the counter. Instead of k, we're putting now n. N is a counter, so 0, 1, 2. So the value of n is 2, right? Pi divided by cube roots. So p is equal to, the cube root means p is equal to 3. Third root means n is equal to 2, because the count is till n minus 1. Okay, so dividing it by 3. So 7 pi by 6 plus 4 pi. So 7 pi by 6 plus 4 pi, and we're taking the whole thing divided by 3. So it's the same thing as saying 1/3 into. So you got 1/3 into 7 pi by 6 plus 4 pi. Right, I'm going to take LCD here. So 1/3 into, 1 second. Let's do this rather. Let's add them up over here, 4/1. So that is 6. That's going to give me 6 here. Yes, and 7 pi plus times 6 times 6, 24. So 7 plus 24 pi here. 24 plus 7, that's 31 pi. And 3 times 6 is 18. So 31 over 18 pi. That's your answer for this. This is for this is only the angle for the when n is equal to 2 and p is equal to 3. This is the cube root, right? And n is the third root. Doing the next problem. So I will stick to your formula, not doing this. Now use WK and stuff. Let's look at the questions. Find the absolute value of the complex number. To find the absolute value is just absolute z, which is square root of -1 squared plus 2 squared. So you're basically just finding the radius, okay? So that will be 4 plus 1, which is √5. Next one. Express the complex number below in a rectangular form. So just open it up. That's just 4. What is cos pi by 3? Cos of 60 is half. Sin pi by 3 is I √3 over 2. 4 times half is 2. 4 times √3 over 2 is 2 √3 I. So 2 plus 2 √3 I. Next one. Let's read this carefully. What is the value of for the first root? First root is n equals 0. For the fourth distinct root. So fourth root is p is equal to 4. Okay. Of the complex number. Remember the angle is theta. Theta is already equal to 3 pi by 4, right? P is that, n is that. So you just substitute into this formula. So theta is 3 pi by 4 plus 2 times 0, 2 times 0 times pi, so that falls off, divided by p, which is also 4. So it's just quarter into 3 pi by 4. So you're just going to get 3 pi over 16. 3 pi over 16, the answer is A. Evaluate this complex number to the power 4. So it's very easy. 2 to the power 4. And take the angle and also multiply by 4. So cos 60 plus I sine 60. That's 2 to the power 4 is 16. Cos of 60 is half. And sine 60 is √3 over 2 I. 16 times half is 8 plus 8 √3 I. 8 plus 8 √3 I. 8 I √3 should be a plus here. Yeah. 8 plus 8 I √3, because that's the only one that's looking right. There's no 8 I anyway. 8 I √3 should be negative I, because it's 15 times 4. We're raising the complex number to the power 4. Express the complex number in a rectangular form. Again, easy. Cos of 30 is √3 over 2. Sine 30 is half. 6 times √3 over 2 is 3 √3. plus 3i, because half of 6 is 3. So 3 root 3 plus 3i, a. Next one, the distance between two polar points. What's the distance between the two polar points? So distance is equal to square root 2 squared plus 5 squared minus 2 times 5, cosine rule, cos theta 1 minus theta 2, 330 minus 150. 4, that is 29, minus 4 times 5 is 20. What's 330 minus 150? 0. That's 180. Cos 180. And now we know cos of 180 is -1, because the cos graph, if you remember, there's 180 here. So that's -1. So we know this answer is -1. Okay. So it's square root of 29 plus 20, which is the square root of 49, which is 7. So the answer is 7 there. Next one. 6 and 120 is the polar coordinate of the point P. Then what is the rectangular coordinates? So easy. X is equal to r cos theta. So r is 6 cos 120. 6 cos of 120 is in the second quadrant. So 180 minus 60 is -half. And y is equal to 6 sine 120, which is 6 times root 3 over 2. So this is 6 divided by 2 is 3 root 3, and that is -3. So -3 and 3 root 3, -3 and 3 root 3, A. Next one. Find the polar coordinates r theta for the rectangular point -1 and root 3, where r is positive and theta is between 0 to 360. So first locate the point -1 and root 3. -1 and root 3 is in the second quadrant. So this is -1 and that's root 3. It's a polar point, right? Polar coordinates. And that's the angle theta. So the radius is 2, root 3 squared plus 1 squared, and square root 2. So what's the angle? Adjacent hypotenuse. The angle is 60 degrees here. So theta has to be 120 degrees. The theta angle is obtuse. That's the inclination angle. So R is equal to 2 and theta is equal to 180 minus 60. The inside angle is 60. We want the outside angle. Right? So 180 minus 60, which is equals to 120 degrees. So what's the answer? R equals 2, theta equals 120. What is the polar form of the equation? So x squared plus y minus 4 all squared is equal to 16. So to find the polar form for this equation, best thing to do will be to open up this entire equation. X squared plus, open up this y squared minus 8y plus 16 is equal to 16. Now you can clearly see the 16 and the 16 cancels out. So the other side is 0. But we know that x squared plus y squared is already r squared minus 8y equals 0. What is y? You remember this equations here? This is x, that's y, that's r. So r is equal to x squared plus y squared. Y is equal to r sine theta. Okay. Now we're going to take this 8r sine theta to the other side. So you're getting r squared is equal to 8r sine theta. Divide both sides by r, we get r is equal to 8 sine theta. Great. So we should get this answer here, B. Next one. Which of the following pairs is another representation of the point -4 and 120 in polar coordinates? So we're looking at polar coordinates. So where's -4 and 120? So we're going to draw a diagram, 120 degrees and 4 first. There's 120 and 4. But -4 means you're going to reflect it down. right? So that's 4, that's -4, and this is 120 degrees. What's another representation for the same line? We can just go down here, right? Uh, to find the same point, instead of doing it like this, to find the same point, you can just go down and make it 4. So that's -60 and 4. Angles on the straight line is 180, right? So that's -60. So 4 and -60 will give me the same answer. 4 and -60. Or how else can we get this red point there? It's 4 and -60. Or we can also say it's -4 and going in the anti-clockwise direction. Yeah. So we can also say it's going in the anti-clockwise direction because we went in the clockwise direction here. What if you go in the anti-clockwise direction and keep the angle as negative? So we can go 360, so it's a -240. Yeah, so you can also say this is -4 and -240. Yeah, so we go in the anti-clockwise direction from there, from the polar axis, and then reflect that across. So yeah, so you can also get a diagram. So -4 and -240. -4 and -240. I don't even have that. -4 and -240. Is definitely not 300 degrees. That's out. Let's use some elimination techniques here. 300 degrees is definitely out. 4 and 60 is definitely out. 4 and 240. Can it be 4 and 240? Going right around. Can't be 4 and 240. Can it be -4 and 240? Right, so 240 degrees going around here. And if I draw -4, I will end up there. Yeah, I think there was an error over here. Just gonna check this up because yeah, there is a problem with the multiple choices. So I think it's 4 and -60. Yeah, should be 4 and -60. What if we try to find the Cartesian coordinate for this rather? What if we try to find the Cartesian coordinate and say this is okay, if I'm using -60, it should be 4. And if I'm using -240, then I'm reflecting it across 4 and -60. That's what it should be. If I'm using 240, if I go around right around here, 240, and then -4, 240 and 4 is here, and reflect across, I will end up there. So it can't be this one as well. It's definitely one of these answers, right? So either this one or this one. So it's not represented there. Find the result of, when you find the product of these two, so you're going to multiply the two radiuses out. So you're going to say 2 times 4 is 8. You're going to multiply the two radii, right? One radii, many radii. 2 times 4 is 8. And add the angles. So cis pi by 3 plus 5 pi by 4. So 8 cis 12, right? 4 times pi is 4 pi plus 5 pi times 3 is 15 pi. So that's 8 cis 19 pi over 12. So the angle should be 19 pi over 12. Cos 19 pi by 12. The full form is 8 cos 19 pi over 12 plus I sine 19 pi over 12. So let's see which one is going to be. 19 pi over 12. That's the only one that works. Yeah. Last one. Find the value of the expression. So this is a complex number. So convert this into polar form. So z is equal to 1 plus I root 3 or root 3i. So we're going to say z is equal to, where's this polar coordinate? 1 and root 3. So 1 here, root 3 there. And that's r. So we know r is equal to 2. Theta angle is adjacent hypotenuse, So this has to be 2. Adjacent hypotenuse, so theta has to be 60 degrees, right? So we have to write this as r cis theta. R is 2, cis theta is 60 degrees. Now raise it to the power 6. So z to the power 6 will be 2 to the power 6 cis 6 times 60 degrees. So 2 to the power 6 is 64 cos 360 plus I sine 360. Right, so you can simplify this. 64 cos 0, take away 360 plus I sine 0. Sine of 0 is 0. Cos of 0 is 1. So the answer is just 64. I hope you guys understood everything.